We're still on Raoult's law, and these two problems here are a little bit different than what we did before. Okay, previously we were actually calculating how the freezing point and boiling point will change, but now we're actually looking for something a little bit different. Okay, because we're not looking for the boiling point that will change, we will actually look for how much mass should be added. Okay, so which means how many moles or how many grams of something should be added in order to change the temperature. Okay, so we're going to do two examples here, one for freezing point and one for boiling point. Okay, so let's look at the first one over here. What is the mass of sucrose added to 75 grams of water to raise the boiling point to 100.35 degrees Celsius? And then the Kb is given to us, okay, for water. So again, now this is a little bit different. All right, we know what the change in the temperature is, we know the mass of water, but we don't know the mass of sucrose, okay, how much we've added. So let's start with the formula here. Okay, we have delta T B, because this is boiling point, is equal to Kb and molality. So Kb is given to us. Okay, delta Tb, yes, we can find that out because that is going to be 100.35 minus 100, and this is degrees Celsius because 100 is the boiling point of water. Nobody needs to tell us that. We already know that. So 0.35 degrees Celsius. So that is the change in the temperature. So which means we are really calculating for molality over here, and then for molality we'll go on. So molality then is equal to delta Tb over Kb, which is then 0.35 divided by 0.512 degrees Celsius molality, and this is degrees Celsius. So cancel that out and you end up getting 0.684 molality, which really, if you think about, is actually moles of solute over kilograms of solvent. Okay, and so for the solvent, that is going to be water for us, which we already have here, 75.0 grams of water. All right, so which means that we will be calculating for moles of solute. So moles of solute is equal to 0.684, and this is moles over kilogram, and then multiplied by the kilogram of solvent. So we just do a cross multiplication here, and so the kilogram of solvent is 0.075 kilograms of water. Okay, so then the moles of the solute is 0.684, my bad, 0.0513 moles. Okay, so again, just cross multiplication to find the moles of the solute. Okay, you need to multiply the molality by the kilogram of solvent. Okay, so once you have the moles, remember we are calculating for mass. Okay, and so molecular weight is grams per mole. So you already know the moles. That's what we're getting from here. So that means that what you need to do is, and you know the molecular weight, okay, already of this. So which means that 0.0513 moles times, and all you have to do is do a unit conversion, and grams per mole, and we have 342.3 grams in 1 mole of sucrose, so which is equal to then 17.5 grams of sucrose. Which means to cause a temperature change of 0.35 degrees Celsius, you need to add 17.5 grams of sucrose to 75 grams of water. That's what it really means. Okay. So that's one that has to do with boiling point. Let's see if, there's one has to do with the freezing point. So what mass of glycine, and again information is given to us, must be added to 1.00 liters of water to make it freeze at minus 1.1 degrees Celsius. Okay, and then the Kf of water is given to us because you will need that. So again, our formula is delta Tf is equal to Kf molality. Okay, again we'll have to calculate for molality because that's the only information we don't have. So delta T here is going to be then 0. minus the 1.1, so that's 1.1. Okay, that's the change in the temperature. So molality is delta TF over KF, and that's 1.1 divided by 1.86 degrees Celsius over molality. This is degrees Celsius up here. So then we have 0.591 molality, and this is going to be exactly what we did up there with the boiling point, is that this is the moles of solute divided by then the kilogram of solvent. So we do exactly what we did before, all right? And so then once we have that, 0.591 molality is equal to moles, we do not know yet, okay? But the kilogram of solvent, we will go with 1 kilogram because it's 1 liter solution. So we can say, okay, we can convert that to 1 kilogram of solvent because it's water, and water's density is 1 liter water is equivalent to 1 kilogram because density is 1 gram per milliliter. So then moles is equal to 0.591 times 1 kilogram, so which means that we have 0.591 moles. And so then once you have that, so 0.591 moles of glycine, and you calculate the mass using the formula mass, which is 75 grams per mole. So this is 44.4 grams of glycine. So that is how much glycine you will need to add to 1 liter of water to make the water freeze at minus 1.1 degrees Celsius.